Hi, welcome to Lesson 20, Session 2. Today we will be continuing our work multiplying unit fractions to find the area. We'll be using area models, we'll be using tiling, and then we will also be using the equation to find the area of rectangles. We are going to be working today in our Ready Classroom Math workbook on pages 407 through 412. So if you can, go ahead and open up your Ready Classroom Math workbook to page 407. All right, so page 407 says this. Titus is making flashcards to use for vocabulary review. He cuts out regular cards that are 1/2 of a foot long and 1/4 of a foot wide. What is the area of one card in square feet? So there's a couple different ways that we could solve this. I'm going to go ahead and show you an area model. And how we could solve this using an equation. As I've mentioned before, many of you will probably default to using an equation, but I really feel like it's important for you to know how to draw area models just because they really help the concept make sense to you when you're thinking about the word problem. So first of all, what is this problem talking about? It's talking about flashcards. And I hope you know what flashcards are. These are flashcards. They're usually like about as big as like maybe a photograph. They're about as big as a picture, and you'll use them way more in once you get into 6th, 7th, 8th grade into high school, because often people will write like a vocabulary word on one side and then flip it over and put the definition on the other side, and you'll use them to practice. Like maybe you've used them before to practice your multiplication facts or to practice vocabulary words. In 6th and 7th and 8th grade, you work on Greek and Latin roots, so you might use that. You might use flashcards for that. So I just wanted to make sure you understood what a flashcard was. Now, what is it that we're trying to solve? We want to know what is the area of one card in square feet. And then the important information is that one side of the flashcard is 1/2 of a foot, and the other side of the flashcard is 1/4 of a foot. So to do this, to draw the area model, the first thing that I'm going to do is I'm going to draw my rectangle. Now, you don't have to draw this to scale. You can just kind of draw a rectangle because you're going to be breaking it apart into pieces, but it doesn't really matter. You kind of want to give it a bigger size just so that you can color in and make enough parts. Now, remember that I talked about how when you multiply two fractions, it doesn't matter which fraction goes in which order, because even if you tell me 1/4 times 1/2 or 1/2 times 1/4, you're going to get the same answer either way. So I'm going to go ahead and put my 1/2 on top of the area model and my 1/4 on the side of the area model. Now, to decide how many columns I'm going to have, columns are going up and down, I'm going to first look at the denominator. The denominator tells me how many parts I'm going to break from side to how many parts I'm going to break this rectangle apart. So I'm going to break it into two parts. So I'm going to draw a line going up and down to create two columns because each of these sides represents 1/2. Then I'm going, well, I'm not going to do this yet. I will get back to there. So we know that the 2 represents how many columns we have. Now we're going to look at the 1/4. So I'm going to actually put a 2 there. Circle that. Now we're going to look over at this 4. This 4 tells us that's how many rows we're going to put going from side to side. So I always like to split it down the middle when I'm making 4 parts, because in half, and then breaking each of those in half one more time. So now I have my columns, 2 columns, and I should have 4 rows. 1, 2, 3, 4. Perfect. Now what you do is you go to the numerator, and the numerator tells you how many sections you're going to shade in. So in this case, our numerator is 1. So I am going to shade in one column. And remember, columns go up and down, rows go side to side. So I'm going to shade in one column because there's a 1 in the denominator. And then I'm going to shade in one row because there's a 1. Actually, I'll do this. You know how much I love highlighting. All right, and then I'm going to shade in one row because that's how many I have in the numerator. So now, the way that I find the answer is, remember, the numerator is the overlap. The denominator is the total equal parts. So in this case, the overlap, how many equal parts overlap? Only one. Just this one. So my numerator is 1. My denominator is how many equal parts there are in the whole. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. So my denominator is 8. So if I want to know what is the area of one card in square feet, I'm going to say one flashcard is 1/8 of a square foot. Oh, how about I add the area of, so there we go. The area of one flashcard is 1/8 of a square foot. Now, again, area model, maybe not your cup of tea, but we are going to be doing them for at least the next 4 days. So if I were you, I would definitely at least figure out how to draw these area models. But you could always check your work with an equation. What is the equation that we're using? We're saying, okay, what is 1/4 of 1/2? Or what is 1/4 times 1/2? I'm going to put of. I love using of. All right, what is 1/4 of 1/2? That's the same as multiplying 1 times 1, because those are our numerators, over what is 4 times 2, which is going to equal 1/8. So yes, do I know that it's so much easier to do the equation? Yeah, I totally get that, people. But you need to remember that you also have to know what it really means. And yeah, this is what I learned when I was a kid, but I never really understood what 1/4 of 1/2 really meant. So I feel like the area model kind of like takes it and goes, hey, Mrs. McGuire, I know that you know how to do this equation, but do you really know what it means? And up until I started 5th grade math, I didn't, but now I do. So don't worry. And now you do as well. So you should be proud of yourself. All right. Now, we're going to go ahead and look, it says here. So this is the same equation or the same problem that we just talked about. Now, and when we look at the picture, it says you can understand the problem by picturing how the cards could fill a square, which, oh, does this look familiar? Very familiar. You can arrange 8 cards, each 1/2 of a foot by 1/4 of a foot to form a square. So we've got our 1/2. In this case, they drew it at the bottom. Doesn't really matter, and they drew the 1/4 on the side. It doesn't matter how which direction they drew it. The picture looks very similar. You can almost see it through the paper to what we just drew. When rectangles fill a square without gaps or overlaps, they are said to tile the square. So this method that we used is called tiling the square. Now, you can model the problem with an equation. Each rectangular flashcard has a length of 1/2 of a foot and a width of 1/4 of a foot. We know that the area equals length times width. So we know to find the area of this one section, we can multiply 1/2 times 1/4. So 1/2 of a foot times 1/4 of a foot equals your answer in square feet. Okay, now we know our answer because we did it on the last page, but I just wanted to make sure that you kind of and you can see why we were multiplying the two numbers to find the area. Now, why can a sheet of paper, why can a sheet of paper, that was my watch, sorry about that. Why can a sheet of paper that is 1 square foot be tiled by 4 rows and 2 flashcards? Well, we know that each flashcard is a half of a foot wide because that's what we were told, a half of a foot long, or I guess a half of a foot long. And so let me change that. I want to change that just to make sure that I use the same words as they use. So we're going to put long and wide. So is a half of a foot long and a quarter of a foot wide. There we go. I want to use the same terminology. So 2 flashcards next to each other is 1 foot. So 2 flashcards next to each other is 1 foot. We also know that each flashcard is 1/4 of a foot wide. So 4 flashcards on top of each other is 1 foot. So 1, 2, 3, 4 flashcards on top of each other is 1 foot. What portion of 1 square foot sheet of paper is represented by each flashcard? So if we're just looking at just this section here, what section is that of the whole? So we know that we have the numerator is going to be 1 because we're only looking at one section. And the denominator is going to be how many sections they're all together, which is 8. So 1/8 of the sheet of paper, or 1/8 of 1 square foot. So one section of this is 1/8. Look at the equation and model it down here. What product of the unit fraction can you use to find the area of one flashcard? So we can say, okay, I know that 1/2 times 1/4. This equation is going to help us figure out the area of this section here. So first, we multiply the denominators of the unit fractions. How does the product relate to the size of the units compared to its size of the whole model? So the product is, so if we multiply the two denominators, the product is 8. Each part is 1/8 of the model. So we know that 1/8 plus 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 1/8 equals 8/8 or 1 whole. So we know that if we multiply those two denominators, we have a product of 8. Each part is 1/8 of the model. When we multiply the numerators, 1 times 1, the product is 1. And we have one part of the picture outlined. So how do we find the area of one flashcard? First, we multiply the length times the width. So what is 1/4 times 1/2? Or what is 1/2 times 1/4? Then we multiply the numerators and then multiply the denominators. 1 times 1 is 1. 2 times 4 is 8. So we know that 1/2 times 1/4 equals 1/8. So we've seen a couple of different strategies of how we can solve multiplying with fractions. So we've seen this method here that we did that we called, this is the area model. We also referred to it as tiling. And then we also know how to use an equation. So which strategy do you like best and why? Go ahead and answer that now. When you're done, you can go ahead and pause the video, write that, put in your answer, and then when you're done, go ahead and go to the next page. All right, number 8 says this. What is the area of a rectangular paper strip with a length of 1/3 of a yard and a width of 1/6 of a yard? Use an area model and an equation to show your work. So first we're going to do our area model. And then over here we will do our equation. So if we're doing our area model, remember that I told you that we just are going to kind of draw like a rectangle. It doesn't really matter what size that rectangle is, but make sure it's big enough so that you can break it into enough parts. I'm going to label each side of this rectangle using the two amounts that we had in our problem, the 1/3 and the 1/6. And then remember that we're going to use the denominator. I'll start at the top. We're going to use the denominator of the 3 to break apart the rectangle into that many sections. So this denominator shows us 1, 2, 3 sections. And then remember, we're going to shade in one section because this is showing that we've shaded in 1/3 of the rectangle. Now we're going to go to the other side and we're going to break the into 6 equal rows. So if we break it into half and then into thirds, that breaks this apart into 6 equal rows. And then we're going to shade in the number of rows in the denominator, which in this case is just one section. And then our overlap is the answer. So we have the overlap is our numerator, and that is one section. And then our denominator is how many sections are in the whole all together. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So the answer is 1/18. But just to check our work, we're going to go ahead and write out an equation. What is 1/6 times 1/3? Well, when we multiply our numerator times our numerator, 1 times 1 is 1. And when we multiply denominator times denominator, 6 times 3 is 18. Now remember, we're talking about yards. And when we multiply when we multiply to find area, it changes to square yards. So the answer is 1/18 of a square yard. All right, let's go to number 9. Marnie has a square picture with an area of 1 square foot. So here's the picture here with an area. That means if you filled in this whole thing, it is 1 square foot. We're going to draw lines in the model to show one way you could tile a 1 square foot with rectangular tiles that each have an area of 1/12 of a square foot. So we want to make it so that we have one section that the area is 1/12 of a square foot. So in order to do this, we need to think about what are the multiples of 12. So what are the different ways we could make 12? So for example, 1 times 12 equals 12. Another way would be 2 times 6 equals 12. And then a final way would be 3 times 4 equals 12. So we could draw this square 3 different ways to make it so that one section equals and has an area of 1/12. So I'm going to like close my eyes and point, and that was not good. All right, we're going to use the 2 and the 6. So if we want to have a product of 1/12, we need to multiply something times something to make it equal 1/12. If we want to get a product of 1 on the top, what do we have to multiply in this case, there's only one option. What do we have to multiply to get a product of 1? That's right, 1 times 1. Okay, now we need to figure out the product of 12. Now remember, I pointed to this 2 times 6, so we're going to use the multiple 2 times 6. So we're going to have 2 times 6. So now we have our rows. Let's go ahead and we'll label the 1/6 down here and the 1/2 over here. Now this is going to look a little funky because we're used to working from this upper corner, but it doesn't really matter how we do it. So we're going to go ahead and we'll do our columns first. This 6 tells us how many columns we're going to have. So we're going to break it in half and then break each of those halves into thirds, which is going to give us 6 sections. And then we're going to shade in one of those 6 sections because the numerator is 1. Then over on the rows, this 2 tells us we have 2 sections, and then we're going to shade in one of those sections. And then our overlap is the answer. And to double check our work, we have one of the equal parts that is our numerator that is the overlap. And then how many parts do we have all together? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that's our denominator. Now this could have worked if we made put a 1 here and if we put a 1 here and a 1/12 here, and then we broke this section into 12 parts and then shaded in 1, that would have worked. We also could have done 3 and 4, and it would have been 1/3 times 1/4 equals 1/12. So that would have been like this. We could have done 1 times 1/12 equals 1/12. We also could have done 1/3 times 1/4 equals 1/12. All of those options would have given us an area of 1/12 of a square foot. For number 10, we're going to go ahead, and the good news is here, we're just going to use the equation. What is the area of a rectangle that has a length of 1/4 of an inch and a width of 1/8 of an inch? What is 1/4 of an inch times 1/8 of an inch? Make sure you multiply your numerator times your numerator to get your new numerator, your denominator times your denominator to get your new denominator, and then choose your answer. You're going to go ahead when you're done and go on to page 411 and 412 on your own. As always, if you have any questions, just email your teacher.